A rectangular concrete beam of width 100 mm and depth 250 mm spanning over a length of 8 meters is pre-stressed with 250 kN force. The cable is straight and is located at an eccentricity of 40 mm from the neutral axis. Given live load as 1.2 kN per meter, then dead load will be equal to unit weight of density of concrete, that is 24, into dimensions are 0.1 meter by 0.25 meter. Then dead load will be obtained as 0.6 kN per meter. Then the total load will be equal to 1.2 plus 0.6, that is 1.8 kN per meter. Due to dead load, bending moment at the midspan will be equal to WL square by 8, which is equal to W is 1.8 into L is 8 meters, so 8 square by 8, which is 14.4 kilonewton meter. So the pre-stressing stress at top will be equal to P by A minus PE by Z plus M by Z, that is equal to P is 250 kilonewtons, so 250 into 10 power 3 newtons by area is 100 into 250 minus P is 250 into 10 power 3 newtons into E is 40 mm by Z is BD square by 6, that is B is 100 into D is 250, so 100 into 250 square by 6 plus our M obtained is 14.4 kilonewton meter, so into 10 power 6 it converts into Newton mm by Z is BD square by 6, so 100 into D square by 6. Individually the values are 10 minus 9.6 plus 13.8, so the resultant value is 14.2 Newton per mm square, which is positive, so it is compression. Whereas at the bottom fiber, it will be P by A plus PE by Z minus M by Z. So the values are 10 plus 9.6 minus 13.8. So the resultant is 5.8 Newton per mm square. It is also positive, so it is compression. So the stress distribution will be at the top it is having a magnitude of 14.2 and at bottom a magnitude of 5.8. Top 14.2 Newton per mm square, positive all over, and bottom 5.8 Newton per mm square. So the second question is, find the magnitude of the pre-stressing force with an eccentricity of 40 mm, same eccentricity, which can balance the stress due to dead loads and live loads at the soffit of the beam, soffit, that is bottom of the center span. Stresses at bottom will be P by A plus PE by Z minus M by Z. So stress at bottom should be 0. Then P by A plus PE by Z will be equal to M by Z. Substituting, taking P as common, area is 100 into 250 plus eccentricity is 40 mm by Z is 100 into 250 square by 6, which is equal to M is 14.4 kilonewton meter, so into 10 power 6 to convert into Newton mm by Z is 100 into 250 square by 6. On solving, P will be obtained as 176 kilonewton.